Hey mathletes, welcome. And I just wanted to do a few examples on finding the domain of some of our functions. We're going to look at this both algebraically and graphically. So first domain, we're going to take a look at the domain of a radical function first. And as we know from our parent functions, the square root of x has a domain of x being greater than or equal to 0, has an interval that is 0 to infinity, including the 0. So we have our first example. Find the domain of the function f of x equals 2 times the square root of 4 minus 3x plus 2. The only part we need to look at is inside the square root. So I'm going to take that 4 minus 3x and I'm going to make that greater than or equal to 0. Now in solving this, the first thing I'm going to do is subtract 4 from both sides, and I have negative 3x greater than or equal to negative 4. Now I'm going to divide by negative 3, and hopefully you remember when you divide an inequality by a negative, it does flip the sign. So now I have x is less than or equal to 4/3. So I'm going to draw a number line here, and I'm going to label 4/3. And since x is less than or equal to, that is going to be shaded to the left and a solid circle. So as an interval, it's going to be negative infinity to 4/3, bracket including the 4/3, and then negative infinity for parentheses. So here's the graph. And we can see right here about 4/3, and everything to the left is included in my graph. I also wanted to connect our function transformations. We know that this negative 3x right here would cause a horizontal flip since it's inside the function of our graph, and that's exactly what happened here. That's also the reason why we need to flip the sign if I change the inequality. So this next example is going to look at what happens when we have multiple solutions with radicals. So I have the function that I need to find the domain, g of x equals the square root of x squared minus 16 plus 5. Again, this plus 5 is only a vertical transformation. I don't need to worry about it. I only need to focus on the inside the square root. So I'm going to take x squared minus 16, and I'm going to set x squared minus 16 greater than or equal to 0. Now I'll add 16 to both sides. So I have x squared is greater than or equal to 16. Now square rooting, here's the problem though. I actually have two solutions. I have the positive and negative value for 4. There are two solutions because this is an x squared. So a positive 4 squared will give me 16, as well as a negative 4 squared gives me a 16. So I do have two solutions that I'm going to need to deal with as inequalities. All right, so x is going to be greater than or equal to 4, or x is going to be less than or equal to negative 4. That's the flipping of the sign because it changed from positive to negative. That's where that plus or minus is coming from. So I do need to split this up into two different inequalities. So now when I go and graph them on my number line, I'm going to have two values that I'm going to be graphing, both a negative 4 and a positive 4. Since it is included, the negative 4, x is less than, that would go to the left. And on the positive 4, solid circle and shaded to the right, since x is greater than. And according to interval notation then, we're going to go from negative infinity to negative 4, with a including 4, so we got a bracket, and then 4 to positive infinity. This u right here represents a union. This is how we can write multiple domains if it has multiple pieces. So now let's look at the graph. Here we have, just ignore the box there. Here we can see that the values of +4 and -4, there's nothing in between on the graph, but it is to the left and to the right. So that fits our domain that we found.